Good morning, students. Next, last topic, that is the relative reactivity of allyl halides with respect to alkyl halides. And this is the last topic in our chapter alkyl halides. So, allyl halides that are more reactive than alkyl halides. What are allyl halides? That is CH2 double bond, CH2X. That is the double bonded carbon adjacent carbon, that is the alpha carbon, and the halogen that is attached to the alpha carbon atom, that are called allyl halides. So allyl halides are more reactive than alkyl halides in nucleophilic substitution reactions, and both types of nucleophilic substitution reactions, that is SN1 and SN2 reactions. SN1 reactions are determined by electronic factors, whereas SN2 by the steric factors. So if we take resonance, that is the first step, having removal of X negative, and there will be, in a case of SN1, formation of carbocation, and that will be resonance stabilized allyl carbocation. So stability of allyl carbocation, that is resonance stabilized, so that will be comparable to the stabilities of secondary and tertiary carbocation, that is the dispersal of positive charge due to inductive effect. Whereas if we take according to SN2 allyl halides, that will be sterically similar to the primary alkyl halides, that does not hinder the approach of nucleophile, because there is no branching and there will be easy approach of nucleophile and formation of transition state and finally product formation. So reactivity in SN1 reactions due to the resonance stabilization, that is the dispersal of positive charge of allyl carbocation, and more stabilization, and that is like secondary and tertiary carbocation. So allyl halides are more reactive, even more reactive than the alkyl halides. Whereas in reactivity, that is in case of SN2 reaction, that is also very reactive, because this act as sterically similar to primary alkyl halides, and that does not hinder the approach of nucleophile. So reactivity will be more than the primary alkyl halides. So in short, allyl halides are more reactive than alkyl halides. Next topic, that is the relative reactivities of vinyl halides with respect to alkyl halides. As vinyl halides, there will be less reactive than alkyl halides, and both by the SN1 and SN2. That is explanation based upon resonance. And if we take firstly CH2 double, what is vinyl halide? Double bonded कार्बन, एंड दैट इज़ द डबल बॉन्डेड कार्बन के साथ जो एक्स नेगेटिव अटैच होगा, दैट इज़ कॉल्ड विनाइल हैलाइड. सो डबल बॉन्डेड, एंड देयर विल बी रेजोनेंस स्ट्रक्चर, एंड देयर विल बी डबल बॉन्ड formation between carbon and halogen group, and halogen group acquires positive charge. So there will be resonance stabilization, but in this there is double bond formation between the carbon and halogen group, and halogen also acquires positive charge. So there will be low reactivity, and there will be vinyl chloride, that is having dipole moment only 1.4 dB, while the dipole moment of alkyl chlorides is 2 to 2.2 dB. So this means vinyl halides are much less polar than alkyl halides. That means contributing structure second, that is there will be difficulty in removal of Cl negative, that is halogen that requires negative charge. There will be difficulty because there is carbon double bond halogen, and there is also positive charge on the carbon atom. So there will be displacement of electrons on halogen atom, on more electronegative atom, that will be difficult, and there will be less electronegative, and this will inhibit the displacement of halogen atom. And another explanation, that is the as a vinyl halide in resonance stabilization, that is the second B, that is the sp2 hybridized, whereas in alkyl halides that is sp3 hybridization. So sp2 hybridized effective size is also shorter, smaller than sp3, then there will be S character will be more in case of sp2 than sp3. There will be greater electronegativity and there will be stronger forces of interaction between carbon and halogen group, and there will be less removal of the halogen, less displacement of halogen group with the electrons. So this will be also less polar and bond length is also less than the alkyl chlorides, and less polar character, and sp2 hybridize more electronegativity than the sp3, so there will be less displacement. So low reactivity of vinyl halides, that will be attributed to two reasons. One is delocalization of electrons by resonance, and second is attachment of halogen to sp2 hybridized carbon atom. It means vinyl halides are less reactive than the alkyl halides, whereas allyl halides are more reactive than the alkyl halides. Thank you, students.